let's talk a little bit about relays. So relays are found in many commercial, automobile, motorcycles, machinery, you name it. And basically the principle is you have a turn on voltage. So this is the basic diagram of the relay. You'll see that there's a positive trigger source, and this would come from your key ignition type switch. And when you turn on your key, it sends 12 volts through that line. And what it does is it'll close number 86 and number 85 at the same or together, which will then cause the contacts between 30 and 87 to close, which will then power your device. So in my case, I have a USB charger as my device. It closes that. I'll show you a specific example. That would come through, and in this case it comes through in on the white lead, which is going to be the powered lead, and the black lead, which is going to be your ground lead. So here is the white lead over here. You can see it kind of behind everything. So what I do, or so what I've done with this circuit is I have a DC power supply, which is going to be my relay turn on circuit. So how I have that wired up is the positive side comes out. It runs through a fuse down here. I have a fuse here. This is only a 2 amp. I'm actually going to blow this 2 amp so you could see what a live blown fuse looks like. It runs through the fuse, through my multimeter, my Fluke specifically, and I'm going to have it reading current so I can check what the current is on the DC power supply here. So the path continues through the Fluke, comes out the other side here, and then it'll go into the white turn on lead, which is the positive side on this particular unit. You can find the diagrams for the various lead or the various relays. I'll show you what this one is and even give you the mock-up of my wiring on this one. So that's the positive side. The negative side for this one just runs directly into the black lead, which is the grounded side of this particular system. So if you were wiring it to a car, you would wire the black lead to your ground, your normal ground. You would wire the white lead essentially to your key switch or some other relay that turns on when you have enough voltage. I'll even show you what the voltage is for this particular one where the turn on is. And we'll do that here in just a second. So that's the powering circuit. On the flip side, or what we're going to power, I'm going to have a 9-volt battery. The positive end goes into the red lead. So what that does is it'll create a circuit. Once it closes, it'll help create a circuit. The negative lead is going to go into my other meter. I'm going to have that one where we can see what the voltage is. It should read somewhere around 9 volts because we have 9 volts coming out of the little battery here. The positive lead here on this particular multimeter is going to touch the blue. So, and the reason I say that is until it turns on, there should be no voltage, which I'll show you that and I'll show you the turn on point. But so the way the circuit works, you'll power it via your key switch or your battery in your car. Most cases, you'll also power your secondary system with the same power. I've chosen to do a 9-volt just so you could show that you could do different things. So you could have other accessories run off of this. Could be a 4-volt, 5-volt, 10-volt, whatever it is, just that you have to have the proper circuitry. So I'm going to show that there's no voltage coming out here. And then I'm going to show you that there's about 9 volts whenever it turns on. And I'll show you the turn on point so that you'll be able to see that. So let's go ahead and get started. So the first things I want to do here, I know there's no voltage. I just plugged up everything. I'm going to go ahead and set my Fluke, which is going to read current, and I am going to set it on 10 amps, which is the highest version this will do. And I am going to set it on amps reading here. Currently it's on AC I'm going to make it DC. And the reason being is we're reading DC amps here. This is powered essentially what will look like a battery or a key switch. So I'm going to do it that way. On the other meter, we're just going to have it, on voltage. It's going to be on auto. And I'll show you here. So right now there's no power going to any of the circuitry. We're going to show a 0. We show a 0. I'll set that down. That was just plugged up to the blue lead. Now what we're going to do is we're going to go ahead and turn on our power supply. I have the power supply set at 0. Typically, I like to turn on the power supply and then hook everything up. It's just so in case there's a transient voltage, transient current. So what I'm going to do here is I'm going to set the amperage to about 0.1 ohm. The reason being is I don't need a lot of amperage going through this in order for it to work. And then what I'm going to do is I'm going to set my voltage. I'm going to go up by 1 each time. And you can see it here. There is no voltage. Effectively no voltage. So we'll go up. You should hear a click once it gets to about 9 volts. I think it's somewhere between 7 and 9 volts on this particular relay. So at 2, nothing. 3, 4, we're at 4 now. We got nothing. Now you can see that we have amperage, going through our circuit. That's the turn on circuit. But currently there is not enough voltage in order for this to close. So what happens is there's enough voltage in here that it'll actually make 2 contactors close. So we'll get there. That's why you'll hear a click sound. So we're at 6 volts, about 0.7 amps. And we are still at effectively no voltage or no voltage. So just to show you here, this is directly to the battery. We got 9.71. So next we're going to get it up to the voltage in order for the relay to close. You just heard a small click. Now what we're going to do is we're going to read the same voltage across that relay. So as you can see here, it is 9.71. And so it's closed that circuit and turned on this power supply. So one of the things that I use this for, very specifically on my motorcycle, I use this, or even in your car somewhat, but I use this to power my phone charger or my phone connection, and I don't want it to always be on. So what happens is I wired it in the same way where I have enough voltage to turn it on when I turn my key switch on. And then what happens is the output voltage will be high enough for us to go ahead and use it to charge our phones or GPS or whatever it may be. It's the same way in your car. If you have a cigarette lighter adapter, if you have plugs like I do in my car, in my truck, I have a 110 voltage as well. It only turns on when you turn on the key. All right, so you can see that we're about 7 volts and it turns on. The true voltage of this should be 12, right? Because that's roughly what comes out of your car battery. It's anywhere from 12 to 14. Could be a little higher, could be a little lower. But as you can see here, we're about 1 amp, we're about 8 volts. So what I have to do here is turn up the amperage a little bit in order to get the extra voltage. So we're at 12 and we're showing about 0.13 amps. My Fluke has it as 139, so it's a 138, so it's a little bit off, but pretty close. The voltage is already still high enough that we'll still be reading 9.71 on the other meter here. So what I'm going to do is go ahead and turn it down, and you'll hear a click. It should be somewhere around 2 volts. And the reason that it should be somewhere around 2 volts or lower is because it's already closed. And what happens is when it's already closed, there's enough electricity at 2 to 3 volts, let's say, to keep it closed. Once you get to 3 volts, it opens up. So we're going to go ahead and do that, and you should be able to hear a click. So we're at 10, still closed. You can check it here. As you can see there, it's still closed. Then we're going to go ahead and go down. This time I'm going to go down to 7. This is where it closed before. So we're at 5, we'll go to 3. So this is at 3 volts. Let's check and see if it's still closed, which I'm expecting it to be. As you can see there, it's still closed. So we're still seeing the 9.71 volts. I'm kind of expecting this to go ahead and open right at this next one, which is 2. I could make it a smaller resolution. Let's see, we'll go to 2.9. So 2.9, it's still closed. 2.8, still closed. It just turned off at 2.4. So now what we can do is we can also look at it just to make sure. As you're seeing here, we're reading 0. So what that means is the actual voltage where it turns off is about 2.5, 2.4. So an example is if you hook this up without a key switch, without that secondary power switch, what will actually happen is if you hook it up directly to your battery could discharge all the way to 2.4 volts before it shuts off. Not common, but it could happen. So let's go ahead, let's blow this fuse that I have here. I'm gonna boost the power, the amperage up to 2 amps, and then I'm going to have it flip over and break. This is a diagram of the relay with the power supply and the battery that I put in and the multimeter and where they were placed. That way that you can just kind of get a real good idea of how I built this. So the DC power supply, the positive side was hooked up to the white wire of the relay, which is number 86. The negative side was hooked up to the black side, which is the ground side, which is number 85 on the relay. And what happens is whenever you put in, as we saw in the circuit, about 7 volts, it closes number 86 and number 85 together, which then in turns closes number 87 and 30 together, which then leads or lets your battery voltage and current flow. So as 85 and 86 close, it causes 87 and 30 to close. So you'll see the positive side was hooked up to the red 30 there from my battery, from my 9-volt battery. And so when it closes, the 30 and 87 come together and it creates like a closed circuit. And I have my multimeter reading voltage in the middle of that, and that was the MK06 in voltage. So this whole thing, is just a circuit. You could have it to where there would be a single ground, so the black would all close together. Or you can have it like I do, which is 2 separate circuits, and that is specifically just to show that you can run it differently. If you were running this off of a single battery, you could have it to where it would be, 12 volts or whatever your battery is. I could have just hooked it up without the DC power supply, but I wanted to show you that there's a turn on voltage and a turn off voltage, or an open and a closed voltage, however you want to talk about your circuit. And like I said, there's, once I close that circuit, we would read the 9.7 volts, whatever that exact number ended up being. And the key here, or the most important thing, is number 86 and number 85 together. They're in a circuit that you will turn off and on. So via, let's say, a key. And what happens is they'll close once the voltage is high enough, and then it causes number 87 and 30 to close on the other side, and that will allow it to run your circuit and provide voltage to the second circuit. All right, let's go ahead and blow this thing. So I'm gonna set it at 2 amps, just under 2 amps, and 2 volts. So we're seeing about 1.9 amps run through this. The Fluke agrees with that. Go ahead and raise the voltage a little bit. Voltage doesn't matter here, but I need it to be in a current mode. And as you can see here, this is 2 amps. We're a little over 2 amps. We're about 2.1 right now. And as you can see, we are still not blown yet. Okay, let's go ahead and go up. We're at 2.6, 2.9, 3.1, 3.3, 3.4, 3.5. We're at 4 amps. This fuse should have blown. 4.3, 4.4, 4.5, 4.6, 7, 8, 4.9. We're at 5 amps. 5.1. There it is, it's getting hot. All right, 5.1, 5.2. It's red hot, which means it should be blowing. We're at 5.5. 6 amps. 6 amps. Took 6 amps to kill that fuse. That's a lot of current to go through that little guy.